Hello grade 9s, this is Mr. Miller and welcome to lesson 6.3 on graphing linear relations. So first example we've got here, we've got Surrey who drives at an average speed of 90 kilometers per hour. The equation relating distance d and time t is d equals 90t. So first we'd like to complete a table of values to represent the relation. So let's consider the times 0 hours, then 1, 2, 3, 4, 5, 6, 7, and 8 hours. And see what we get for d. So plugging in t equals 0, 90 times 0 gives you 0. Then 90 times 1 gives you 90. 90 times 2 gives you 180. And so on. You can see how this progresses. 270, 360, 450, 540, 630, and 720. So we can plot all of those points on the grid here. So here we have the distance axis, which is being measured in kilometers. And this is the time axis, which is being measured in hours. And so this is your basic distance versus time graph. And so plotting these points, so 0, 0, that's the first one. Got 190, 2, 180, 3, 270, 4, 360, 5, 450, 6, 540, 7, 630, and 8 would be up to 720, which is just slightly off the grid. So now we can connect all of these points together because it does make sense to talk about the in-between times. So for instance, at half an hour's time, you would expect to drive 45 kilometers, and there's no reason why we can't have all of the points connected in between here. So I'm going to do that now. Now the next question is asking, how long does it take Surrey to drive 630 kilometers? So of course I can see that here from the table that 630 kilometers it takes 7 hours to drive. But if I wanted to do that just strictly graphically, I could look at the 630 kilometer level here, and I could work my way across make a mark if it wasn't a well-known value, and then drop down to see how long in time that would take. And of course you can see that's 7 hours. So this corresponds to what we found in the table here. And this is one way that you can use a graph to solve a problem. So showing the relationship between distance and time here, and finding out the amount of time it would take to do a certain distance. So again, that's 7 hours that you would write here. Okay, moving on. Next page says for each linear equation we want to create a table of values and create a graph. So for the first one, we've got b equals negative 2a plus 5. So got a and b values, and we can start with some easy a values like negative 2, negative 1, 0, 1, and 2, and we can calculate the b values from that. Since it seems in this relationship that b is dependent on a, that would put the dependent variable here on the vertical axis. Independent variables tend to go on the horizontal axis. So now we're going to use this equation over and over again. b equals negative 2 times the a value plus 5. So calculating that, negative 2 times negative 2 is positive 4, and adding 5 to that will give us 9. You can do the same thing for each one of the next values that follows. So negative 2 times negative 1 plus 5, which would give us 2 plus 5 is 7, and negative 2 times 0 plus 5, which gives you 0 plus 5, and that's 5. And you start to see a pattern emerging here, which is that every time we're increasing a by 1, we are decreasing b by 2. So negative 4 plus 5 gives us 1. So we can plot all of these points on the grid here. So negative 2 and 9. So negative 2 and 9 is up here. And negative 1, 7 is right here. And 0, 5 is right here. And 1, 3 is here. And 2, 1 is right there. Now this only takes me part of the way across the grid. Of course, I could certainly continue this pattern beyond that, so I could continue to go down 2, right 1, 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 down 1, right a half. That takes us right to the edge of the grid here. And typically what we would do for this straight line to indicate that this line does continue on in both directions is that we would put arrows on the ends. So this line, I'm going to indicate that it continues on in both directions by putting on some arrows. And there we go. So now the next relationship we'd like to look at is t equals negative 3. So there's no real indication whether this should go on the vertical or the horizontal axis. But for this one, I've decided to put it on the horizontal. There is no other variable, but let's say that I just put another letter here, and let's make it u. And so I'm making t my independent variable, and u is my dependent variable. And I'm going to take a look at what happens here. Now, no matter what, t is going to be equal to negative 3. So for every single value of u, whether it's negative 2, negative 1, 0, 1, or 2, or it doesn't matter what else it could possibly be, we're going to have negative 3 for t. So now let's put these, each one of these ordered pairs on the grid. So for instance, negative 3, 2, 1, 2, 3, 2 is right here. Sorry, we're supposed to be looking at negative 3, negative 2. Negative 3, negative 1, negative 3, 0, negative 3, positive 1, negative 3, positive 2. And you can see the pattern here, which is that all of these points are lying on the same vertical line. And now I can indicate that this line continues on in both directions by putting arrows on the ends. All right, now the next one we have is g equals f over 4 minus 2. So f is the independent variable and g is the dependent variable. So normally what I would do is take some small f values, but I'm going to be a little bit more particular this time because I know that if I do -2, for instance here, -2 divided by 4 gives me a fraction. So instead of using -2, I'm going to start with -8. And then I'm going to go to -4 and 0 and 4 and then 8. And you'll see why as I do the calculations why I chose these values. And it's pretty easy to figure out. It's because dividing by 4, I want to end up with a nice integer value. So doing -8 divided by 4 and taking away 2, that gives me -2. Take away another 2, which gives me -4. And -4 divided by 4, take away 2, is -1, take away 2, which is -3. And 0 divided by 4 is 0. Take away 2 from that, I get -2. 4 divided by 4, take away 2, gives me 1, take away 2, which is -1. And 8 divided by 4, take away 2, gives me 2 minus 2, which is 0. So now let's put these points on the grid. Again, f being the independent variable, I'm going to put that on the horizontal axis, and g on the vertical axis as the dependent variable. And there's a few different ways of telling whether you have an independent variable or a dependent variable. Typically, the dependent variable is the one that will be written on its own in the equation as a function of the other variable. In a table of values, the independent variable tends to come first, and the dependent variable tends to come next. The independent variable tends to go on the horizontal axis, while the dependent variable goes on the vertical axis. So those are a few things that are good to know about types of variables. So now putting these points on the grid, -8, -4. So now -8, -4 is not going to fit on this grid because you can see it only goes to -5. So I'm not going to worry about that first point. Let's start at the next one. -4, -3. So -4, -1, 2, 3. I can certainly fit that one on this grid. And then 0, -2 is right here. And 4, -1 is the next point. And 8, 0 is the next point. And there you go. You can see that these points all fall in the same straight line. We've got that same pattern of going up 1, right 4, up 1, right 4, up 1, right 4, up 1, right 1, 2. I could even put a hypothetical point out there, just give you an indication as to where it would continue on from here. Now, I'm going to join all these points together with a nice straight line. And of course, I'm going to put arrows onto both ends just to indicate that this relationship would continue on in both directions from there. And that's that. So now let's take a look at what we have next. It says for number 3 that we want to create a graph and a linear equation to represent each table of values. The first one is pretty easy to figure out. We have y and x here, and you can see that no matter what the x value is, we always have y equals 4. So with x equals -3, we have 4. With x equals -2, we have 4. And all the way across here, for all of these different x values, we have the same y. It's always at 4. And that creates a horizontal line at y equals 4. So again, I'm just going to put arrows on the end to show that this does continue on. And typically, when you graph a relationship, it's a good idea to put the equation for this here. And the equation is pretty simple. It's just y equals 4. So it doesn't matter what x is, y is always equal to 4. Next, we'd like to look at this relationship between a and g. And when I look at relationships between variables, typically I look at the dependent variable first, and I say, how is this one changing? And you can see that each step we go along here, we are increasing by 0.5 each time. While if you look at the change in A, each time this is going up by 1. And so an important thing to do here is to look at what is the change in G over the change in A. And that 0.5 divided by 1 gives us 0.5, or a half if you like. And so we could certainly figure out that there is going to be an equation that goes G equals a half times A plus something else. Now to figure out the plus something else, we need to work backwards to when A was 0. So, of course, we've been taking steps forward here, going up 1 each time. What if we went back 10 steps? What would that look like on the G side of things, going back 10 times 0.5? That would take us down 5. So it would take us down to G equals 3. And so that value of 3 is the plus something else that we can put in here. So again, let me just go over how you can come up with the equation from this table of values here. So first of all, we look at the change in G. And it's the change in G over the change in A, which will give us this 0.5 or 1/2, and that is the coefficient of A. It's also called the slope of the graph, and you'll see why it's called the slope after we get the graph done, and we can take a look at that rise over run. And now there's one other piece here, which is the G value when A is 0. And that is 3, and that's how you come up with your plus something else here in this equation. So now we've got an equation, and we want to plot all of these points here, connect them with a straight line. So starting at 10, 8, so 10 and up to 8, and 11, 8.5, 12, 9, 13, 9.5, 14, 10, and 15, 10.5. If we worked, again, working backwards to x, sorry, not x, but we had A here for the independent variable, then we get G equals 3. So now connecting all of these points together with a nice straight line would go like this. And again, you can put arrows on both ends just to indicate that this relationship does continue on in both directions. A couple of interesting connections to make here with the graph and the equation and the table. So one of the things that's interesting to look at is the fact that this plus something else, this G value when A was 0, is the place where we cross the g-axis. Another thing that is nice to note is this 1/2 is our rise over run, and it is called the slope because every time, so let's say I start from this particular point right here and I go up 1, then I go right 2. Again, I go up 1 and right 2, up 1 and right 2, and that pattern can continue on, creating these little steps or slope triangles, which indicates how steep this line is. And they're really handy for finding other points on the graph too. So hopefully that helps to get you connected with the table, with the graph, and with the equation for the graph. So now the last relationship here that we have between two variables is between t and d. And when we're done, maybe we'll say, ta-da! Just kidding. All right, so, well, I mean, you can say it if you want. Let's take a look at the change in d. So we're going up by 1/4 each time here. Going up by 0.25. In d, while t is just going up by 1 each time. And lucky for us, in this table we can see what the d value is when t is 0. That's -2. So you can use both of these facts to come up with our equation. So we take the change in d over the change in t, 0.25 divided by 1, and that's 0.25 or 1/4. And so we're going to have that d is 1/4 t plus -2. Or just subtract 2. So d is our dependent variable, and t is our independent variable. And we're going to put these points on the graph here. So starting at 0, -2, and the next point was 1, -1.75, and we had 2, -1.5, 3, -1.25, 4, -1, and 5, -0.75. And we could certainly follow the same trend backwards. Of course, I could just use this slope of 1/4. I know that we go up 1, right 4, so I could certainly trace that backwards. 1, 2, 3, left 4, down 1. So continuing that same slope down and to the left. And now I should be able to connect all these points together with a nice straight line. And just to show that it does continue on, I can put arrows on each end of this line. So that completes this lesson. I have lots of examples here. Hopefully you're feeling comfortable with that now. Thanks for watching the video and have yourself a wonderful day. Bye-bye.